Hello, and thank you for joining us today. I'm U.S. Air Force veteran Xavier Peterson, and I'm one of the business development directors assigned to the federal sector here at Blueprint Technologies. Blueprint is based in Bellevue, Washington, and is a technology company known for its consulting products and services. We are digital transformation specialists, and in the past few years, we've expanded our commercial successes to focus on the needs for innovation within the federal government agencies. Today's topic is finding the competitive advantage in data for federal agencies. I'm excited to hear from two of our major industry partners, Microsoft Corporation and Databricks. From Microsoft, we have U.S. Army veteran Kevin Calkworth, Cloud Solutions Director, DoD and National Security. From Databricks, we have Howard Levinson, General Manager and Vice President. These two thought leaders will share differentiators that make them leaders in the federal sector in areas that impact data use with machine learning and AI across multiple agencies: accessibility, speed, security, and innovation. The partnership between our three companies is at the core of delivering value to our customers, public and private. The power and breadth of Azure and the speed and secure access of Databricks, and the focus on real, relevant outcomes by Blueprint enables us to deliver the right solutions for our customers and their specific needs. In addition to our industry partners, we'll be joined first by U.S. Air Force Colonel Michael Teeter, Chief Data Officer, U.S. Space Command. I look forward to hearing his discussion and more about his role at Space Command, which includes data management, governance, policy, and emerging technologies. In the commercial sector, competitive advantage is what makes a customer choose one business over another one. By understanding and promoting such an advantage, companies can win greater amount of market share. Conversely, in the federal sector, I think of competitive differentiation as continuing actions to outpace our current and future threats across all agencies, winning today's engagements and preparing for tomorrow. We have two demonstrations of ways in which our three companies can help you leverage technology to find the new pace and unlock those advantages. We know that technology alone is not the answer, but when it is used as a powerful platform that enables us, we can work more efficiently, strategize further out, solve problems in new ways, and demos the partnership with Microsoft as the background of each demo is developed using the power of Azure. It's a direct reflection of integration of technical components and the power of possibilities with the two partners. First, we will hear from Zafar Balalolu, Senior Solutions Architect at Databricks, on how to use all of the data that you already have with some machine learning tools on their Lakehouse platform to drive towards predictive maintenance. This can help us reduce operational overhead and interruptions to service and missions, ensuring consistency and predictability on bases and in the field. Finally, one of my personal favorites for today highlights our own Blueprint company. So today we're joined by Blueprint's very own Gary Nakanalua, Managing Director of Innovation. Innovation is not something you direct with precision, and it's not always possible to pick where the best opportunities will be or know which data sets will drive the most value. Gary has the best value product demonstration that has resonated with the federal sector, and our video analytics tool, Nash, is now on display at the Microsoft MTC in Reston, Virginia. Please take advantage of this live event and make good use of the chat. If you have any questions, please drop them in the chat. We'll address a couple of them at the end if we have time. Otherwise, we'll follow up with you separately after the event. It's now my pleasure to turn it over to my colleague, U.S. Army veteran, Ivan Eno, for the remainder of the session. Ivan, take it from here.
Thanks, X. Good morning, everybody. Really happy to be here. Happy to be spending some time with folks. My name is Ivan Eno. I work with Blueprint really to help drive the adoption of some of our commercial best practices in the federal space, and I'll be helping coordinate the Q and answer and the moderation discussion today. So I know we're trying to get Colonel Teeter up and running, so I think what we'll probably do at the start is, Kevin, I'll start with you. As the Cloud Solutions Director for the DoD and National Security, I'd love to get your insight into how we maintain that decision-making advantage compared to our strategic competitors. Kevin?
Yeah, I appreciate that. This is one of those topics of conversations we have a lot, right? And so obviously coming from a military background, I have a vested interest in making sure we're always pushing to get the absolute best out there and really thinking outside the box. And one of the ways we really think about doing that is really looking into our commercial successes, and look at corporations and other entities and what they're doing with the use of data analytics to really not just remain competitive, but to have that competitive advantage, right? So I can give you a couple examples when we talk about a convenience store or a retail outlet, right, where they're now using technology where they can heat map the traffic within stores. So they can look at the movement of individuals around the store. They find different ways to help basically improve that process and be able to look where are things working really well, where are there log jams, where are there issues based on spillage, just congestion around a lot of people, or there's misplaced items. And we think about some of those core technologies that go into that, and we can turn those same applications over into peacetime, governmental, and other various different downrange instances, right, where we can take advantage of those same types of technologies. We also looked a lot around, you look at hardware manufacturers, you look at supply chain logistics companies, where they're looking at that modernization efforts around their entire logistics. So we've got companies who are making hardware products and they watch weather patterns to look for, okay, there's a tsunami coming in this location within 5 days, so we want to shift where our actual components are coming from to prevent any supply chain downtime. And in the same motion, we're looking at their warehouses and different areas where they're like, okay, how do we basically automate a whole bunch of this or improve safety factors by determining when there's equipment where there shouldn't be or where there's people where there shouldn't be. And we have a lot of those same applicabilities in motor pools and with a lot of our airframes downrange. And so what we're really trying to push now is thinking, my challenge for everyone is always, don't ask me what your peers are doing, what various different other people are doing. Think outside the box and look at what are some of the best and brightest in various different fields doing, and how do we take some of those learnings and best practices. And that feeds a lot, right? And when we talk about our partners, such as Blueprint, yourselves, and Databricks, and we do this hundreds of times a week with the entire spectrum of types of customers, accounts, government organization, everything else. And we want to help utilize a lot of those learnings to expedite the actual end state results, because we know oftentimes the hardest part, right, is just that starting point of understanding the data where it exists now, what you're doing in that space, and what you're trying to accomplish. And so one of those big ones for me is like, what are we trying to get out of that, right? It's all around the idea of that decision advantage. So that core kind of question you gave us is, we want to put the decision-making capability in the hands of the people at the very front line. What we used to see, I know for me 10 plus years ago, is we would have analysis being run for multiple days before actions could be taken. And so now if we can slim that down to minutes in some of the best case scenarios, and we can share that data across multiple different teams or organizations and different efforts or agencies together, then we're able to basically go from 60% confidence to 90+% confidence, and being able to take that action almost immediately with the individuals who are there in the situation versus having to play relay race for a couple hours first. So it's really around creating the confidence and ability to do those types of things. That's just fundamentally important for us.
I really appreciate that insight, Kevin. As a follow-up question, I'm sure you've had experiences with a number of organizations that are very different points along their technical journey. And at the same point, we know that there's agencies that are at very different points in their technical journey. So how do we as integrators and technology providers make sure that we meet our customers wherever they are in that journey to make sure that we're minimizing the downtime and the time to production for quality systems?
I don't know. I'm always told that day one, you just click a button and you're done. AI is there. It's funny. We often have these conversations of, to really get the results and the insights you want from artificial intelligence, from machine learning, and the actual prescriptive actions, 90+% of that work is simply it's the data wrangling piece, right? It's understanding your data estate. It's verifying that the data is good, that it's trusted, that it's reliable. And then you start thinking around, okay, what are the skills of the individuals who are trying to run these analyses or create these outcome-based events? And so in order to do those things, you're exactly right. It is a journey. It's not a, hey, let's pick one thing. We want to go do a shiny object and that's the day. For us, it's always around its culture. And so one of the big things that we look at when we look at partners, right? Like we mentioned, the Blueprint, the Databricks of the world, we're looking for those partners who understand that it's around a complete paradigm shift around how you approach this. So you have to have the right executive buy-in. You have to have the cultural understanding that if you do it right, you're failing and pivoting and iterating a lot. And it's not just day one, day two, it's continuous. It's a process of continuing improvement. If you've ever read the book, The Goal from long ago. But to really do that right, we're thinking around, you look at that maturity curve from going from descriptive analytics all the way to prescriptive. So where you're being able to tell what was done in the past to actually making recommended actions based on what we think is going to happen in the future. And so going through that, it's sitting down and it's working side by side. It's helping the individuals assess, okay, where are we? Where's our time and energy best spent? Is it really learning to code in Python? Or is it utilizing a different set of tools so we can focus more on the data and the outcomes and what we're trying to accomplish? And as you do that, you help build the storyline with them. You help educate the right executives, the right chain of command to understand how long it's going to take, what's going to go into it, and really understand that longer term roadmap of what you're trying to accomplish. You want to have some quick wins early, but you've got to build towards that longevity and sustainability of outcomes with AI and ML versus just trying to rush to the finish.
Thank you so much, Kevin. Ruthie, have we got Colonel Teeter available?
Hi, Ivan. Can you hear me?
Yes.
Okay, excellent. I am actually going to, I have Colonel Teeter on my phone right now, just because we have some technical difficulties. However, he is going to be speaking and he can hear you right now.
Perfect. So just as a quick reminder for everybody listening in, Colonel Teeter is the Chief Data Officer and Deputy J6 for Digital Superiority at U.S. Space Command. So, sir, I really appreciate your time and thoughts this morning, and we'd love to hear your perspective on the relationship between the private sector and DoD when it comes to real mission-based planning and innovation.
Yeah, I appreciate it. Thank you, Ivan, and I apologize for the technical difficulties. And can you hear me okay?
Loud and clear, sir.
Okay. As Ivan said, so I'm the Chief Data Officer and the Deputy J6 for Digital Superiority at U.S. Space Command. And it's a new position that General Dickinson stood up really to get after one of his key tasks. He put out his vision and with 5 key tasks. So one of the key tasks is maintaining digital superiority, and with really the idea of again, we're not in this alone. It's a partnership with industry, and in this forum here with Databricks and Blueprint and Azure, here you see 3 companies coming together and really getting after mission-related problems. And within space, we are a large producer and consumer of data and information, and the transport of that information, the storage, the analysis is vital for us, and that's why he stood up this position. And as I go forward, interacting with industry and partnering with industry and building our partnerships is absolutely. We just came off of the Space Symposium, which is the largest industry space conference last week out here in Colorado Springs, and a part of that again was interacting with industry, and really within the space realm right now you see a lot of activity and a lot of interest, and really commercial starting to lead the way there. It used to always just be kind of behind the door, US, Russia in space, but now you're seeing there's 20 spacefaring nations there, and with that, the industry. I mean, we all saw the first commercial flight where you could fly into space, with Jeff Bezos and Virgin Atlantic doing their flights, and all of that to say that we are ingesting this data now, and just to get after space domain awareness, which is the amount of objects in space and the amount of data that produces. An example, I know we're talking predictive maintenance model here, but with our sensors around. You have ground sensors and your radars, as well as your phased array, are all looking into space and producing these large amounts of data. But the maintenance schedules on these, when they go down, if it's not predictable, then it can really make it hard for us to defend the homeland and to get after our space mission. So I think we absolutely have applications that you're going to see today and these demonstrations that are going. And for example, when you get into the machine learning models, the conjunction analysis, right, in our mission of supporting the human spaceflight support and the International Space Station, having the ability to run models of going into doing debris analysis. So two satellites collide, they're going to produce a field going across, and that field is going to have second, third order effects, or years down the road run into other satellites. So we want to be aware of those actions so we can notify our allies and partners, notify industry. So I know Databricks has been doing great work with the Space Force, and with some of the other pieces you're going to see here. Blueprint is again doing great work, and Microsoft is. And so I want to take the time, again, apologize for the technical difficulties here, but wanted to really take the time and effort to really emphasize the importance of the industry defense partnerships, and even amongst industry coming together and working together, that it's not vendor locked, it's not stovepipe of work with us and no one else. Seeing forums like this where you see three companies come together to really get after the national defense is great. And so I really appreciate your guys' time and everybody being a part of this discussion.
Colonel Teeter, thank you so much for your thoughts this morning, sir. Much appreciated. Howard Levinson with Databricks, as GM, Regional VP, I would love to get your thoughts and insight into the advantages of being an Azure first-party service, and also how you've leveraged that partner ecosystem really well as a team and as a company to drive innovation and facilitate problem solving.
Yeah, happy to respond to that, Ivan, and honored to be following Colonel Teeter and Kevin in this great webinar. Before I respond about the first party service, which is really critical, I thought maybe I could just give you a couple of minutes on the background of who Databricks is and what we do for the viewers here who might be unfamiliar. So our founders started at UC Berkeley some number of years ago, and they created and open sourced a framework for doing big data analytics. What made this framework kind of unique and really the de facto standard in the marketplace was open source. It handled structured, semi-structured, and unstructured data, and really became the background for doing data engineering, data warehousing, and data science. In fact, we've combined the best capabilities of data warehouses, the ability to work with structured data, run SQL queries and reports against it, as well as the best capabilities of data lakes, which allow you to deal with semi-structured and unstructured data and allow you to run machine learning models. We smash those two together and we create something we call a lakehouse. The things that make the lakehouse unique are it's simple, because now my data engineers, data scientists, and business analysts are all delivering off the same data and the same environment. It's collaborative so that they're working together on building the data sets in the right formats for consumption, and it's completely open. Not only is it open source, but the format of the data that's stored in ADLS, Azure Data Lake, is an open format that anybody can read. Now, these things have propelled Databricks to become one of the largest and fastest growing SaaS companies in the industry. We started 5 years ago, and today we support 350 of the top Fortune 500. So really great success, 5,000 customers. Now, one of the things that happened was Microsoft recognized some number of years ago that they needed to provide a best-in-class big data framework for their clients. But instead of just making Databricks available on the platform, we entered into what I would consider to be the most strategic partnership in my 30 plus years in this industry, where Microsoft actually takes and co-engineers the Databricks product, and we integrate it directly into Azure, and we call the platform Azure Databricks. What makes it really unique and really compelling is that it's integrated deeply into the Azure ecosystem. So when you start using Databricks in Azure, all of your Active Directory roles and responsibilities are accepted. The integration with tools like Azure Data Lake and Cosmos DB and Synapse and Azure Data Factory and Azure Event Hub, all of these things are tightly integrated together. So it's not just an independent use of Databricks, it's the entire Azure ecosystem that you can take advantage of by using Databricks. The other really cool things about being a first-party service is for many of our customers, there's no separate contract. If you have access to Azure, you inherently have access to Azure Databricks. And for our federal clients, it means that Azure Databricks meets the same levels of compliance that Azure that's required for federal use cases. So things like FedRAMP High, IL5 in support of the Department of Defense and the Air Force and Spacecom. These are really hard characteristics to meet, and Azure Databricks meets all of those capabilities. I'd also like to point to a couple of use cases in terms of how our customers are using Databricks. And I'll share with you one commercial one, which I think is relevant to the Air Force. Organizations like Rolls-Royce, who produce aircraft engines. A typical aircraft engine, the sensors on it collect over 1 terabyte of data for every hour that aircraft runs. When you take this and sum it up with all of the aircraft engines that Rolls-Royce produces, you can do predictive analytics at a scale and a level that's never been done before. And by using Azure Databricks and the whole Azure ecosystem, Rolls-Royce has been able to grow their market share by producing higher quality engines from 20% to 50% in just a few short years. So that's one example, but you know what? There are others that we partner with Microsoft on, like the Center for Disease Control uses Databricks now to manage the vaccine rollout. Department of Transportation is responsible for regulating the on-time arrivals, and they use Azure Databricks to track that information. The US Postal Service delivers the mail on time and gives updates in terms of the package delivery systems by leveraging tools like Azure Databricks. And it's the capabilities that Microsoft brings together, along with organizations like Blueprint, who have this tremendous expertise in using Azure Databricks and using the Azure ecosystem to help our customers be successful right out of the gate. So hopefully that's not too much there, Ivan, but I'll pass it back to you if there are any questions.
No, that's perfect. I appreciate it. I think what you described has a lot of direct relevance to our viewers today. Do you want to go into a little bit more detail, Howard, on how you've seen users that have really siloed data sources, how you've helped not only integrate that platform, but how have you helped affect culture change within that user base to make sure that as they're getting that new information in that new format, they're really able to leverage it?
Yeah, it's a great question, and it is really a key question for many of our federal clients because I don't know, I'm sure you've seen OMB did a study and the federal government had 12,000 data centers not too long ago. So if you think about each one of those data centers and the number of operational data stores that they have in each one of them, the best way to get value out of your data is to bring it all together and use the data to enrich other data sets and to federate that data together. That's one of the things that Databricks does great. The ability to read data from just about any source. One of the really cool things about Apache Spark and Databricks is you can read an XML file, you can read an Oracle file, and you can read a JSON file, and then your next command could be a SQL join of those 3 data sets. That's really powerful. And pulling all of that data together into a lakehouse like Azure Data Lake is really the defining approach for doing big data analytics. But you also talk about the cultural aspects. If you really want to leverage your data, most organizations have data engineers, and these people are responsible for transforming that data. But they have to transform it into a manner that's useful for business analysts and for data scientists. And very frequently, we see that the data engineers do that transformation, but it's in the wrong form for the data scientists. And so they have to redo it. The data scientists spend 80% of their time by industry metrics doing data engineering. The collaborative capabilities that Databricks offers allows the data scientists to work directly with those data engineers, making sure that when those transformations are completed, they're in the form that the data scientists need. And that brings about the cultural change that you describe. And I would say bringing all of this data together from these islands of data that federal agencies have today is probably one of the most powerful starting points in the industry.
Thank you so much, Howard. I appreciate your thoughts. So at this point, I think what we're going to be able to do is pass it over to Zafar Bilalalu, and he's going to give us a demo on Databricks.
Thank you. Yeah, before we jump into a quick demo on Databricks, whoops, let me just share here. Yeah, before we jump into a quick data on Databricks, just a quick recap of one of the use cases that Howard mentioned, doing predictive maintenance on the Databricks platform. An example of a Databricks customer doing this is Rolls-Royce. So they need to be able to better manage airplane engines to ensure uptime and efficiency and reliability. And they have a product called Total Care, which works by offering a flat $1 per flying hour rate to airlines that covers all the engine maintenance costs. It transfers the cost of uncertainty from the airline to Rolls-Royce. So Rolls-Royce is really incentivized to keep all of their engines up and running. And why they chose Databricks for this predictive maintenance use case is it enables Rolls-Royce to stream in flight data and combine it with external environmental and conditions data. And upon landing, they use Databricks to run a predictive maintenance routine, which is run for each engine, identifying which parts need to be repaired before the plane is pushed back. And the impact of using Databricks for this predictive maintenance use case is it effortlessly allows them to scale to an increasing number of sensors and planes. And the Databricks platform enables Rolls-Royce to perform maintenance analysis and ensure availability of engines without negatively impacting their customer on-time objectives, and essentially allows their Total Care business to have higher margins as well. And the architecture that allows this is the Databricks Lakehouse architecture. Again, you can bring in all of your data, whether it's structured, semi-structured, unstructured, streaming, or batch. Manage it with our Delta Lake layer and add governance on top of it, and then empower all of your downstream use cases, whether that's data science and machine learning, like the Rolls-Royce use case, or BI, SQL analytics, data engineering, real-time applications, all with one simple open collaborative platform. So jumping into our demo here. And in this example, we're just a quick overview of the architecture for doing predictive maintenance on Databricks for windmill IoT data in this use case. We typically see customers bringing in for predictive maintenance use cases, sensor data. So this can be historian data, which is common in manufacturing and the energy sector. We also see vehicle-specific data, geospatial and telemetry data coming off of sensors in the vehicles. This can be joined with unstructured data, such as images and video feeds of vehicles and machinery. And it's also very important to merge this IoT data with traditional data sources like ERP, maintenance logs, historical purchase patterns. And in this example, we're going to be ingesting two different types of data sets. We have a simulator here that's generating simulated IoT data. We're going to be reading in turbine sensor readings from windmills. We're going to be using PySpark structured streaming to be able to read this data as soon as it comes in a streaming manner. And we're also going to be reading weather sensor readings, contains information like temperature, humidity, wind speed, which we want to join with our turbine sensor readings to be able to make predictions. So I won't dive too deep into the code here. This is essentially the code that we have to be able to process our data and write it out to tables in our Delta Lake. And the big takeaway here is as soon as our data is processed by Spark Streaming, it's ready for analysis using SQL. So here I'm writing a SQL statement to be able to query my data, and analysts can jump in and start analyzing this data as well. And you can see some of the raw data here. It contains information like RPMs and angles from the turbine data, and then temperature information from our temperature sensors. Next, we want to do some data processing now that we have our raw data. We're going to build some silver and gold tables. And for this example, we're going to build hourly aggregations. But you have a lot of flexibility here to do multiple silver tables and do aggregations, you know, every minute, every 10 minutes, daily aggregations based on your use case. And our gold data here is going to be the final copy of our data that we use for predictive analysis. This is going to be the final copy of the data, and it's going to be enriched with some additional information such as maintenance data, as well as power being outputted from the turbines as well. So we have our processing code here to create our silver and gold tables. And again, the big benefit of this architecture is once these pipelines are built, they'll just run, and as new data comes into our system here, it'll be processed automatically into these bronze, silver, and gold tables that contain these various transformed data sets. It's just set it and forget it, and then start streaming in the data from tools like Azure Event Hubs or IoT. And then you also have the capability to backfill historical data. Perhaps some data came in late. With Delta, you have the flexibility to be able to do updates and inserts and merges with late arriving data, so we can update our previously calculated aggregations. And just what some of this final gold table looks like, you can see we've joined our two data sets with maintenance data, power output, as well as the original RPM and angle and temperature humidity data. So now our gold tables are ready for predictive analytics. We have hourly weather, turbine operating, power measurements, and daily maintenance logs going back 1 year. And we can see there's a lot of correlation between these variables, such as RPM leading to increased power output. So we want to be able to build a model to be able to predict when these turbines might need maintenance, as well as future power output. So that's what we'll be doing in our next notebook here. And Databricks, what we provide for machine learning is a runtime with over 150 popular open source machine learning packages, tools like TensorFlow, PyTorch, Keras, others pre-installed, so you can get started modeling very quickly. You don't need to spend time doing DevOps to get your computing cluster environments ready. As a data scientist, you can just jump in and start using your data to be able to build predictive applications. And in this example, we're going to use XGBoost framework to train our regression model due to the size of the data and number of turbines. We're also going to use Spark UDFs to distribute our training across nodes in a cluster. So we go over some of the steps here, doing feature engineering to be able to enhance our data set to be able to feed into a model here. We won't dive too deeply into that example. Here's an example of doing distributed model training on Databricks. Databricks has the ability to use Pandas UDFs to be able to vectorize Pandas code and distributed across a cluster. And here we're using a UDF to train a XGBoost regressor model. After we trained our model, we can stop plotting predictions, comparing it to our actual labeled data, and we can see the results of some of those plots here. And the big benefit that Databricks provides for model tracking and training in Databricks is all of your models are easily reproducible. Databricks will automatically log using MLflow auto logging any input parameters to your models to be able to track things like input metrics, output values of models, any artifacts that are created as a part of the modeling process, feature importances. All of this is done automatically for you with MLflow. It allows you to easily be able to reproduce your model and see how you've run various different models across our platform. And the next example we're going to do in the previous one, we predicted power output. We're also going to train another model for doing power output or predicting remaining life on these wind turbines, so we can know when a windmill will need a maintenance event. So we have historical maintenance data here that shows when a replacement occurred. We're going to use this to calculate the remaining life as our training label here. Again, we use an XGBoost model to be able to predict the remaining life based on operating parameters and weather conditions. And here's just a visualization here of our predictions versus actual life remaining. And now that we've trained these models, we want to be able to deploy them into production, be able to serve out actual operational predictions to people out in the field maintaining these different windmills. So we have a lot of capability to do that with Databricks. We can integrate with tools like Azure ML to be able to serve the models over a REST endpoint. We have that capability in the Databricks platform as well, just a single click to be able to take a model you've trained through our MLflow UI and be able to deploy it. So this goes over examples of being able to do that. And then doing additional things like asset optimization calculation. So now that we have a model that can predict power output and life, we might be able to want to optimize for ideal operating conditions for maximizing power output while also maximizing useful asset life, so we can run calculations on the platform to be able to do that. And then ultimately be able to serve this the predictions of this model out to our end users. You know, if a model's not put into production and you don't have dashboards that render the results of that model, it just essentially ends up being a science experiment. So we have the ability to integrate with tools like Power BI and be able to serve out these predictions to end users through easy to use dashboards and graphs on the Databricks platform. So this leads into your data warehousing workloads, be able to easily integrate your ML models and serve them out to your end users using easy to use dashboards. So that's all I had today for a quick demo of Databricks. I'll be handing it back to the Blueprint team for a overview of their Nash demo.
Zafar, thank you so much. Really appreciate your thoughts today. So Gary, I'm excited. I know you are. As the Managing Director of Innovation at Blueprint, I think the idea of being able to leverage Microsoft and Databricks technology to really rapidly iterate on customers who have proof of value that they want to see or proof of concepts that they want to have demoed. I'd love to see Nash and hear how it sort of fits that rapid prototyping process.
Yeah, absolutely, and thank you. And we'll go ahead while I bring this up. One of the interesting things is, as Xavier mentioned earlier, Nash is a video analytics tool. Video analytics in and of itself isn't new, but like Kevin and Howard noted, we use commercial technology to solve mission-based problems. And so working with Microsoft and Databricks, we actually we're working with a couple of federal intelligence agencies to actually take a look at how we can use video analytics so they could integrate video into their own workflows on a day-to-day basis. And the interesting thing about that was the use of video within their space wasn't new, but as Kevin noted earlier, the speed upon which they could actually get any sort of insight from that video, it would take days. And so that speed to decision making and analysis is one of those competitive advantages. And so speed wasn't exactly on their side when it takes days to process video. So what you're looking at here, this was and is a tool that we worked in partnership with Microsoft to build. And it's built upon the concept of earlier, Howard mentioned, hey, a lot of times data scientists spend a lot of time doing data engineering more so than actual data science work. And what we wanted to do is, what would it look like if an intelligence analyst actually partnered up with a data scientist, and what types of interesting questions would they ask, and what types of analysis would come about from that? And so Nash came about first and foremost as this collaborative video analytics workspace upon which then pattern of life analysis could be conducted. So I'll go ahead and just kind of jump in and show that. So I'll load up a sample workspace here. So if I take a look, and we'll load up this one. So here what you're looking at, I'll get ready to play it, is you'll see some footage of traffic camera. And so the first thing you'll notice is that Nash is identifying vehicles within this footage. And then across the entire video itself, it's identifying all the different objects, but it's also looking at the different events and behaviors exhibited by those objects in motion. And then finally, based upon the events and behaviors over time throughout this video asset, it detects anomalies as well. And all of that was a lot of fun, but one of the things the intelligence agencies noted was, we're really good at finding answers, but it would be great if it could help us ask more questions. And one of the questions was, based upon the events and behaviors exhibited in this particular area of interest, what are some other areas of interest that we should be looking at? And so based upon that, Nash actually recommends other video assets where the events and behaviors and anomalies that are shown actually exist in some percentage in other videos as well. And then all of that with the analysis that is being done, that data scientist and analyst team, they can actually go in and adjust the model, all the different inputs. So as they start to understand the different questions that they're going to ask, and the sort of what ifs and the experimentation from an analysis perspective that they want to conduct, they can actually go in and adjust that along the way, and then actually rerun the analysis to see what comes out on the other side. And then kind of coming back around to the speed aspects of all of this, we're actually able to process video within minutes versus hours or days. And that all comes down to just, number one, Nash is built on 100% Azure as a cloud platform. It actually allows you to switch between CPU and GPU processing. So you can speed up the processing as fast as you want to. We also segment the videos and run them in parallel, which is another sort of behind the scenes. So here what you're looking at is the pipeline that Nash itself actually builds. And so very much in the Databricks demo previously, this pipeline is established by Nash, and you can just rerun your videos through this pipeline, and you find yourself with this entire video analytics processing pipeline that, again, you have control over the processing time. So whether it's a few minutes, a few hours, you can scale it up and down thanks to Azure. And then as you can kind of see here, the one other piece to kind of take note of is it isn't just limited to vehicles. In this particular case, the model that is being demonstrated is for vehicles, but you can actually, instead of having one massive machine learning model behind Nash, its architecture actually supports multiple models along the way. So whether it's specific vehicle types, whether it's particular object types, all of that analysis and from those models, as well as the models themselves, can actually be baked into NASH itself, which makes it incredibly versatile for whatever the mission may be.
Awesome. Thank you so much, Gary. So, as folks in the audience are thinking about potential problems to solve, can you help them understand what the timeline was from identifying this as sort of a proof of concept to getting that product in the Azure marketplace?
Yeah, this one was interesting because we wanted to work through with Microsoft and these intelligence agencies. What does that video analytics sort of solution look like? And so from the moment the sort of, hey, how do we integrate in video analytics to the overall analysis workflow to when we actually submitted NASH as a solution to the commercial Azure marketplace, took us just shy of 60 days from start to finish. And the thing to understand about that, and this was mentioned earlier, I believe it was Kevin, it was a lot of experimentation. This was not a situation where all of the requirements had been defined up front. We knew what the mission was. And so based upon that, just leveraging our own methodology and Azure, and again, Azure Databricks is part of that processing pipeline. It allowed us to accelerate really, really fast and get NASH built in just an incredibly short amount of time.
Thank you so much. We have time for a few questions, so I'll kind of read a few of these questions and let our panelists chime in with their thoughts. The first one is, we've talked a little bit about how we are leveraging commercial best practices into the DoD space, and the question is, have there been any sort of DoD best practices or lessons learned that then get turned around and leveraged in the commercial space? So Kevin, I'd love to pass this one to you. What are your thoughts?
Yeah, absolutely. And I apologize. I may have replied in private as well to that individual, but so one of the big ones I call out right now is that need for a lot of the edge compute scenarios. Like Gary was just kind of showing, like when we start going to the more GPU heavy scenarios, there's a combination of edge capabilities and then also that true mesh hybrid network where you're connecting a bunch of devices that can communicate together in a very limited bandwidth scenario. We've seen a very few instances in the past where some railroad companies and others need to try to shoot information up via 3G, but they were sending, I'm talking bytes when they could, and then waiting for an area where they could actually send more data. And so the DoD in this instance is actually pushing a lot of the technology capabilities forward because we can't wait around for those answers. We need the hardware to drive it now. And secondary is a lot of the hardware form factors themselves. So what are the actual compute capabilities in a smaller box? And then what are the battery needs? So the efficiency of the boxes as well. And being able to do more and more of that analysis at the edge so we can drive, just like Gary's showing, a lot of those insights and actions. And so those are two areas right now where we're going to see, similar to the first iteration of GPS and some other scenarios where we're going to see the DoD driving that.
Yeah, thank you so much. Howard, anything to add to that?
No, I definitely agree that the federal government has a unique requirement to process data out at the edge, particularly the Department of Defense. And we have Army clients, for example, that build and create their machine learning models. One of the really cool things about Databricks is you can take those models and export them in a Docker format or in another standard format where the model can be used for inferencing in the field in combat situations on cell phones or using 1U devices and make analysis that way. So that's something that we don't see as much in the commercial space, but we're starting to see more of that in manufacturing environments. The U.S. Postal Service, it has similar requirements. So we're starting to see that type of edge detection or edge inference take place more often in commercial.
Yeah, thank you very much. And I've got time. I'll get one more question out there. Howard and Zafar did a great job in their demo of sort of highlighting how the use case of aircraft and engines that have all of these sensors on it can be leveraged to drive predictive analytics. So the question is, in the case where you may not have those sensors, how can organizations or agencies get ahead of the predictive maintenance problem? And Howard, I'll start with you on this one.
Yeah, I think we might have overemphasized a lot of the examples that I gave at the CDC and Rolls-Royce indicate that the data is coming in real time. A lot of the data is retrospective. Think about in the U.S. Air Force, all of the F-15s that are out there, all of the training flights that those take, all of the service records, all of the climate information that goes around that, the geographies that these are flying in, because we know that sand can have an impact. You take all of those records and the actual failures, and you can build a machine learning model with just manual record keeping that will allow you to predict failures better than you do today. So yeah, it's great to have all of that sensor information that comes in real time, but there's so much more beyond those sensors. And that's when we talk about integrating all of these different data sources. Those sensors may not have GPS on them and weather collection devices. That data may come from other sources like Air Force weather. So when you take all of these data points and you put them all together, whether they're manually entered or automatically ingested, there's a wealth of data there that can be used for predicting failures.
Yeah, thank you so much.
No, I totally agree, Howard. With the ability to ingest, maintenance logs and unstructured data, that really unlocks a lot of power there. So.
Thank you very much. So as we get into the last few moments of the webinar, I know Ruthie is going to share a screen that helps direct folks to follow up. So we've created an address just so that you know, as listeners, if you have any questions or would like any follow-up, please reach out to the address that you're going to see on the screen. All three companies will have access to the traffic that you generate. So whether it's a question that's better answered by Microsoft, Databricks, or Blueprint, we'll make sure that we direct you to the right folks. I really want to thank Colonel Teeter, Howard, and Zafar, Gary, Xavier, for your time, thoughts, and insight here. This webinar in our mind is the first of a series as we start to focus in on the specific needs in the federal agencies that can be solved by this team approach. So again, thank you everybody very much for your time and thoughts. You should see the contact us at federal@bpcs.com. And barring any other last minute alibis, I think that's it for the day. Thanks everybody very much.